Okay, so now we are going to talk about the units of temperature. We said before that there are four units of temperature for the unit systems that we mentioned. We have the temperature of, or the units of Celsius and Kelvin for Kelvin and Celsius for the SI units, the Fahrenheit and Rankine for the American units. And it's important to understand the difference between Kelvin and Celsius and Fahrenheit and Rankine. Of course, we know how to convert the units, but it's important to understand the concept of having both. When you measure the temperature of anything, it has to be measured relative to the absolute zero. Which means that when I say the temperature in Kelvin, for example, is 300 Kelvin, it means that it is 300. This is the actual temperature. It's 300 Kelvin. Relative to the absolute zero, which is the real zero. In case of Celsius, the scale was adjusted so that we have numbers that are easy to understand, and this is the main importance of the Celsius and the Fahrenheit, is that the scale is easy to use. So, for example, in the Celsius scale, we have a scale that is something that you can feel easily. You understand the 0 is the freezing point of water and 100 is the boiling point of water. So you see the ice, you can see the ice, you can touch it with your hands, and you can feel how cold is it. And you can see the boiling water and you see how hot it is. So the scale from 0 to 100 is something that is easy to feel. Okay? And this is something that we mentioned about the units in the very beginning, that one of the very important things about the units is that it is something that gives you a feeling of the quantity, and this is what the Celsius can help us with. The Celsius scale gives you a feeling of the temperature from 0 to 100. You feel, you saw and touched the 0 by yourself, and you saw and touched the 100 by yourself, so you see it means something in your mind. When you hear 0 Celsius, you hear 100 Celsius, it's something that makes sense to you. So this scale is not measuring the actual temperature, it's measuring the temperature relative to the freezing point of water. So the 0 now is not the actual 0 of the temperature, it is the freezing point of water. You made a reference for you and you are measuring all the temperatures relative to this reference. So the temperature in Celsius is not the actual temperature. The actual temperature is the temperature in Kelvin. But Kelvin doesn't give you the feeling of the numbers, so you are using the Celsius scale. So that's why we call the temperature in Kelvin the absolute temperature. This is not an absolute. It is relative to the freezing point of water. Okay? So this is why we have the two scales. The same for Fahrenheit and Rankine. In case of Fahrenheit and Rankine, is that the Rankine is the absolute temperature. 0 Rankine is the same as 0 Kelvin, but the Fahrenheit is a scale that is means something else. It means a scale that makes something or something that you can feel, that is not relative to the absolute 0. It's relative to, I don't know what, but the 0 Fahrenheit is something that I don't know what it relates to. It's not like 0 Celsius. 0 Celsius is the freezing point of water. I don't know 0 Fahrenheit. Maybe it relates to some other material. But anyway, so this is the difference between the two units, or the absolute and the non-absolute units. So it's important to keep this in mind, that the Celsius and Fahrenheit are relative to a standard value. And that's why they are easy to use in the daily life. It's more convenient to say that the temperature is 40 Celsius than to say it's 313 Kelvin. That's why we use it. And just something to keep in mind, that in our engineering applications, in I would say 85 to 90% of the cases, we use the absolute temperature to do the calculations. Otherwise, something else is mentioned, but in general, this is what we use. We'll talk about temperature later again in more details, but this is what I want to mention here, and I'll see you next time, inshallah. Goodbye.